Something interesting happened when Broglie said, if we can view light as both a wave with a wavelength or as a photon, as a particle of energy, then can't other particles or objects be viewed and their energy / location be described by a wavelength? And so we have a kind of famous equation that we need to just introduce you to and learn how to use and see why it's unimportant. The de Broglie relation relates wavelength to a mass of an object and its velocity. So this is not frequency, this is velocity. To use this equation, you have to use, these are SI units, in order for the units to cancel correctly. And the thing to kind of watch for is that mass for the SI unit of mass is kilograms, not grams. And also velocity is meters per second. So anyway, we need to make sure we have those units to plug in there. The reason that, this led to being able to look at electrons and their positions in terms of wavelengths, which allowed for an electron microscope to be made. But most objects are large enough, their mass is large enough, that their wavelengths are so small that we don't notice that their position or location is actually in a wave function. So let's go to an example. Okay, so we have a mass, this is a velocity, and we're looking for wavelength. Our equation, but we have to be careful because we need SI units. Kilograms we have, we need seconds, not minutes. We need, everything else is good. And of course, we need meters instead of kilometers. So our speed needs to be, we need this to be in meters per second. Our mass is okay, and then we should be good. So let's convert our speed from kilometers per minute. Okay, and getting everything to cancel there. Okay, and then we're ready to plug in. This is Planck's constant on top. Planck's. Okay, and at this point it may just look like, oh, those units aren't going to cancel, what's happening? And the thing is that a joule is the same thing as a Newton meter, or a joule, if we plug in what a Newton is, or another definition, I think it gets more complicated than that, but anyway. So if you plugged in this for the joule here, we would see that the units all cancel such that your wavelength comes out in meters. And I'm not going to go through that. I made sure that my units were SI. So if the position of a moving object is varying by this wavelength, we're not going to be able to see that. Sometimes students think that the wavelength has to do with electromagnetic radiation and its wavelength, which is, this would be a very scary kind of radiation because its wavelength is so short. It's not. This is the wavelength associated with the position of a moving object.